Okay, let's see this question. This is a polynomial of degree 4. So the higher degree. So usually what do? We want to reduce the power by using a dummy variable. So let's see. In this case, we let k equals to x plus 2. So in this case, we can rewrite these two expressions. Right? We see 3 minus 1 is 2. So we want to write x plus 1 as x plus 2 minus 1. And then x plus 3 will be x plus 2 plus 1. So, yes, we're rewriting this. Then we look at x plus 2 as one thing because k, right? We just name it as k. So that becomes k minus 1 to the first power and k plus 1 to the first power. So it's easier, right? Then we square it. So this is to the first power, but let's just take a second power first. So second power is perfect square. We get a k squared minus 2k plus 1. And this one we get a k squared plus 2k plus 1 squared. We still have this square form. Right? Then, so with these two, we see we have k squared plus 1 in common. K squared plus 1 minus 2k and k squared plus 1 plus 2k. So again, we have the beautiful form. We're treating k squared plus 1 as one thing. If you want, you can use another dummy variable to substitute. You could use a t or s. Let's say, okay, let s be k squared plus 1. But for me, I just keep it as k squared plus 1. So I treat k squared plus 1 as one thing. So I get a k squared plus 1 squared, because to me, it's k squared plus 1 as one term. So I have think about it as s minus 2k squared, I get a perfect square again. So get the first term square, which is k squared plus 1 square. Then minus 2 times 2k times k squared plus 1, my middle term. Then plus 4k squared. Same thing for the second term, right? I'm treating k squared plus 1 as one term. Think about as t. I have t plus 2k squared. I have perfect square again. So get the first one square, which is k squared plus 1 square, plus 4k times k squared plus 1 plus 4k squared. Now you see when I add those two, the middle term canceled. I have negative 4k times k squared plus 1. I have positive 4k times k squared plus 1. Those two had to be 0. Now the equation is simplified to be 2 of k squared plus 1 squared plus 8, because I have 4k squared plus 8k squared. I can factor out 2. Factor out 2, I have k squared plus 1 squared plus 4k squared, right, equals to 82. Now I can divide by 2 on both sides. I get, then I get another perfect square, k squared plus 1 squared, which is a perfect square again. So I get the first one squared, which is k squared is k to the fourth power, 2 times k squared, then plus 1, plus this 4k squared. Well, 82 divided by 2, I get 41. Now, I have even it's a fourth power polynomial, but I can use quadratic, right, strategy to solve this equation. If you want, you can use s, let s be k squared, right? Then you have s squared plus 6s minus 40. In that case, you see that's factorable, right? Negative 40 can be factored as negative 4 times 10. Then when you add 10 with negative 4, you get the middle term, 6k squared. So factor out as k squared minus 4, k squared plus 10, right? Using 0 property. So the first factor can be 0, the second factor can be 0. First factor gives us k equals plus minus 2, two solutions. Then remember k is x plus 2, so substitute back, x plus 2 equals plus minus 2. So we get two solutions, we get 0, we get minus 4. What about the other factor? Well, k squared plus 10 in real number world will never be 0. So just ignore this, right? So to this, in the end, we have two solutions, 0 and negative 4. So let's go back to the fourth polynomial. So 0, if x is 0, we still have 1 to the fourth, 3 to the fourth, 3 to the fourth is 81, 81 plus 1, yes, 82. Or negative 4, right? Negative 4 minus 1, that's negative 3. Negative 3 raised by 4, 81. Negative 4 plus 3, negative 1. Negative 1 raised by 4 is 1. Add together, we get 82. So two solutions.